I'm Maria, and I'm going to present you how to do data flowing the easy way. First of all, I want to talk a bit about myself. I'm a software engineer. I started working on 2009 with route calculation and maps and location. And then I continue exploring this geospatial area, and I quite like it a lot. And at some point in 2019, I start working for Red Hat, and then I changed a bit the topic I have been working on, and I moved from the geospatial side to how to create integrations and how to create automations and how to make lives easier both for developers and DevOps and even people that want to run things like analysis or workflows of data, but they are not quite sure how to create them by implementing them with code. Well, I don't know, this is an introduction talk, so there may be people that are just starting with programming, or even they haven't even started yet, they are just exploring what computer science is. So I just want to start by trying to explain what software means, or what is a code that is flowing in a machine. There are many definitions of what software is. For example, this Flourish definition by Ada Lovelace, which is the mother of all computing. A software engineer defines and designs a flow of the software they create. So on a classical program flow, usually described with UML diagrams, it describes how based on some input data, you get some output data. Sometimes there is no input data because it's just trying to trigger some algorithm that will get some output with no input. Sometimes the output is just the algorithm finished. There is nothing to show. But in the end, you can describe software as you have some input data, you do something to that data, and then you output some data in the end. On more complex situations, maybe you have different small pieces of software, which we can call them components or modules, and then you want to make the software interact with, so the components and modules interact with each other. And in the end, you can see it again as I have some input data that goes to some component. This component interacts and sends data back and forth to some other component. And this other component in the end have some output that may go to a third component or go back to the first one or just finish the flow of the program. So as you can see, the idea is very simple. And if we check the Wikipedia definition of what software is just a collection of instructions and data that tell the computer how to work, which is exactly what I have been explaining. Why I'm explaining this? Because sometimes when we want to interconnect different components, what we do is write ourselves and implement and write the code of the pieces that the glue, the middleware that are in between the components. This orchestration of components, defining how they interact with each other, how they send data back and forth, or the type of transformation you have to create to send the data back and forth. Usually you write your own code and then you have to maintain your own code in the future. Maybe your code has some bugs or has some unexpected use case that you didn't think of those use cases at the beginning when you define how your software is going to work. Or maybe you're using some library that at a later stage gets updated, and then you have to update your code to update the library, or just update the library, but you have to care a lot about maintaining the code if you want it to keep running. And in the end, what we are doing is repeating once and again the same patterns, the same pieces of code. For example, I connect to this database, I extract the data, and I push it to some REST API. And this connection to the database, once you have done it 3-4 times, you realize it's always the same. The sentence, the exact elements you are extracting from the database may not be the same, of course, but the way of interacting with the database is always the same. And you end up using libraries and some connectors to simplify this. And then again, when you connect to some API or when you connect to some component, it may be you are tweeting something, it may be you are connected to Salesforce, it may be you are connecting to an FTP to upload some data. It's always the same. And it looks like there's a lot of developers. There are thousands of developers in the world doing exactly the same things again and again, repeatedly, and stepping onto the same mistakes, because we all make mistakes when we develop code. So wouldn't it make sense to have something that helps us creating these pieces of code that are always the same? So instead of having to write a lot of code for this interaction, we just tell, hey, this is a database and I want to extract this data. And this is an FTP and I want to save this XML or this JSON or this image in this FTP. Wouldn't it make sense to have some framework that allows you to do this easily? Well, that's what integration frameworks are for, to create data flows the easy way, so data is flowing the easy way. A proper integration tool or proper integration framework should provide us with the following features. First, it should have a lot of connectors to existing protocols and components. So it's not just this framework allows me to communicate with HTTP APIs and database. No, I want to have the more types of connectors, the better, because I don't know, maybe in the future I have to connect to some message stream, or I have to connect to some, I want to send a Telegram chat, some update, for example. So I want that my integration tool has a lot of connectors. I want that it has transformations. So for example, I'm receiving an XML and I want to send a JSON to the next component. I want to be able to transform this. And also it should have integration patterns, which I will explain a bit later. Let's start with the transformation. So I said that sometimes you want to change maybe the format, but it's not only the format. Sometimes what you want to do is also change the data you're doing, maybe the data you are handling, maybe by adding some attributes or removing some attributes or adding some calculation and changing some of the attributes or the data you are using, you are sending. For example, if you are grabbing a list of items, maybe you are not that interested in the list of items, but you want to collect how many items there are or how many items of a certain type there are, and that's what you send to the next component. So you should be able to do this kind of transformations and define this kind of transformations on the simplest way possible, because the less code we have to maintain, the better. And once we transform this, we should be able to, of course, connect it to the next component. Then transformations is not the only thing. We said that we need a lot of connector types, we need transformations, and then we need integration patterns. Integration patterns means that usually when you have some integration, some flow, it's not linear. Maybe you have a flow that has a conditional in some step and say, okay, if the data I'm receiving is a list, I want to iterate over all these elements and do something different for each element. Or maybe I want to check if this is an error. Did I receive an error from the previous step? If I received an error from the previous step, maybe I don't want to continue the flow. Maybe what I want to do is try again or send an email to the system administrator or warn somehow that this was an error and I can continue. So there may be conditional steps or conditional steps that defines if what I'm receiving is some kind of element I want to do something. If this is a different kind of element or has different kind of attributes, I want to do something else. Or maybe it's just by the time or conditionals can be about anything. And you can, of course, iterate. You can, maybe you want at the beginning of the flow, you iterate over a list of elements, and at the end of the flow, you want to aggregate again the elements, or aggregate in subsets of elements. So you kind of close the flow into smaller threads, or you want to, there's many of these patterns that can happen on a flow, and these are called the enterprise integration patterns. As you can search for them. There's a classic book about enterprise integration patterns, but they are quite similar, and they are very similar to what you can imagine to a flow, how they work. So that's what we need on a good integration framework. Integration frameworks, there are many integration frameworks. You can find them with restricted license, so you can only use them if you pay a license, or you can only use them under certain circumstances. There's also open source software frameworks. And what I'm going to talk today is about one of these open source frameworks, which is Apache Camel. And I want to talk about this framework using an example, because I have been talking about a lot of abstract concepts, and maybe that's not the best way to understand exactly what this means. So the example I'm going to showcase here is a very simple example. Is an implementation of a software that an animal shelter can use to run cat adoptions, for example. So we have like two kinds of inputs. There may be a new cat coming to the shelter, or there may be a new person coming to the shelter looking to adopt for a cat. So the abstract flow for this software is pretty easy to understand. When a cat enters, I want to register it somehow as a cat waiting for adoption. And when a person enters, I check if there is any cat available that has matched with this person. If there is a cat available, that person can adopt a cat. If not, I will have to tell that person, sorry, we don't have any cat available. You have to come at a later stage or go to another shelter. So the idea is very simple, but if you have already worked implementing this kind of flows, you know that it doesn't matter how simple the original idea is, how simple the requirements are. In the end, you have to write a lot of code to implement this kind of stuff. So let's move about to what the software architecture may look like. This is the implementation I decided based on the requirements, because why not? I think it's pretty simple. So I'm going to have Kafka broker that receives the JSON. I decided it's going to be JSON, because why not? The data, and then in this case, the data will be stored on a database, which is, on my case, going to be Postgres, but it doesn't really matter. And on the case of the person, it arrives on a Apache Kafka broker. You check the database to see if there is any cat available, and depending on what happens, you will either register the cat as it's already taken, or, sorry, we cannot give you any cat. I introduced Apache Kafka, and I didn't say what this is. Apache Kafka is what the website says. It says it's an open source distributed event streaming platform used by thousands of companies, high performance, streaming, blah, 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 integration. To put it simple, Kafka is a very light messaging service that allows clients to receive and send messages. So you can listen to a broker, which is like a stream of data. And when a message is received, when someone enters a message there, you will receive the message. It doesn't care about what kind of message it is. Kafka doesn't care if it's XML, if it's JSON. It will just take the message as is and send it to you. I needed an entry point, and I decided that Kafka is cool, so why not? I could have used RabbitMQ. I could have used, I don't know, any other type of entry point for messages. So this means that we have two different components, the database and the Kafka brokers, and we want to connect them with some logic So the logic, the conditional, when I receive a cat, it's going to be stored in the database. And as I said, we usually see this and say, this is pretty fairly easy use case. Let's just start by implementing this. And then you have to create the data models, to create a connector for the Kafka, you create a connector for the database, you create the transformations from the JSON to the database SQL, then to the query on the SQL. And then you have to handle the password authentication of the database. You have to have a listener created for the Kafka broker. You have to worry that if your application gets broken or your listener gets some weird input, how to handle that error, because maybe someone writes the message of the new cat incoming wrongly or confuses JSON with XML, and then you have to be prepared of what will my application do when I receive some message that is not valid. So I want to simplify this. I want to use the integration framework and forget about all these little details that once you try to put this in production and deploy this and make it work, you will step into this kind of mistakes unless you create a lot of, you have a lot of experience, you already have done this a lot of times, and then your code is huge because you consider all use case, which is good, but then it means a huge code you have to maintain. I'm going to talk about Camel because I mentioned it. We are going to use Apache Camel, but I didn't explain what Camel is. So it may be that you have never heard about Apache Camel, but you should know that this is one of the most active projects inside the Apache Software Foundation. Maybe you have heard about Apache because the Apache server is very well known, but Apache Software Foundation is a very big foundation that has a lot of projects under its umbrella. And one of the most active or most visible ones is Apache Camel. And it's not only one of the most active ones, which is always good because that means someone is maintaining this piece of code for you. It is also free and open source software, which is always guarantee of quality and good practices because there's a lot of eyes looking at this. There's a lot of people refactoring, and there's a lot of work into making this framework good. And it's also at least in my opinion, I haven't done a very through statistic on this, but I think it's the lightest and most complete integration framework available. Why do I say this? Because there are many other frameworks, integration frameworks that focus on having a nice user interface or focus on having this kind of connectors that are very complex. Camel tries to be very simple. And even if it supports hundreds of components and protocols and formats and transformations, they are very well defined, so it's very easy to use, and it has its own DSL, which is the domain language, which means you can write code in this DSL to tell Camel what to do step by step, and it makes it very simple. I'm going to show, after these slides, I'm going to show you a demo, and you will see that the amount of code you have to write is negligent. It's the minimal. You have to tell about there is this database that exists, and the Kafka broker you want to connect to is on this URL, and not much more. Camel is also available in Knative with the name Camel K. Knative is Kubernetes, try to create OpenShift, try to create a more virtual native environment, so you can deploy this on a Kubernetes and have your transformations running, your integrations running all the time, and you don't have to worry about having a separated application for this. And CamelK is knative, which means it's the performance over Kubernetes or native platforms is higher than if it was a normal Java or C or Python application. And Camel is also available over Quarkus, which is supersonic subatomic Java. Camel is written in Java, but it's a very, very well written Java. So don't worry about it being huge. It's really, really small and very quick and very fast. And even if Camel is written in Java, you don't need to know Java to use it, because as I said, it has its own DSL, and it allows you to write in Java-like language or JavaScript or Groovy, or it has a lot. You can write your pieces of DSL code in the language you are more comfortable working with. So it's really, really very good for almost any use case where you need to integrate things. If we want to take a look at how Camel works on the inside, it has different pieces that connect each type of component. Here the components called external system, because I don't know, I made this slide thinking external system. These connectors can be a connector that reads something on external component, which we will call consumer because it's consuming the external component, or they can write something on an external component, which we will call producer. It doesn't mean that the consumer only listens, because maybe you need to query first and send something to the external system to receive an answer. But the idea is that you separate these two concepts. I want to modify, write, warn the system, which is the producer, or I want to consume the system, which is the consumer. And between a reading from a component and the writing to the next component will be the router. So the router separates each step of the flow. The router is the piece of software that carries most of the logic and decides what is going to be the following step. So there is where the iterations and conditionals and loops happen. The data that flows from the consumer to the producer is encapsulated on a type of message we call exchange. You can see there in purple. And the idea is that exchange is understood by all the components, all the connectors in Camel. So you can easily connect between, for example, a stream from HTTP to an FTP. Camel understands that the FTP will be expecting a file, but the stream is going to send you a stream of bytes. So Camel automatically converts the stream to a file, so you don't have to worry about conversions, which is one of the places where a lot of mistakes are done when you are writing your own implementation. We can link this piece that I showed you before, the consumer, router, producer, together, forming a chain of commands, which is what will define the flow. So this way, the exchange will move from one component to the following, to the following, to the following. Well, the join of a consumer and a producer for the same component is what we call an endpoint. These are words, consumer, producer, endpoint, which we don't really need to use Camel. But if you are looking to use Camel, it makes sense that these words are starting to sound, so they are not foreign when you start reading the documentation. And remember that any good integration frameworks allows you to have conditional statements, parallel processing, similar integration patterns. So on our cat adoption case, we will have one conditional that decides if a person adopts a cat or not. And on this case, we are not going to iterate over any list of elements, but remember that something you can do. These pieces can be combined, so you can create a flow that is as complex as you want it to be. You can even send back some data, so you create loops. Although I don't quite recommend that, because Camel is very, very smart, but if you create an infinite loop, it will not know it is an infinite loop. So I recommend you, I suggest you, I encourage you to not do loops if you can avoid it. Just write somewhere that there has been an error, you have to go back and then call it separately again. So you have somewhere stored that this was a loop that was called again. The exchange that carries the data has many elements. This is, again, something that you don't really need to know to use it, but we are explaining Camel, so why not? Obviously, the exchange carries the data itself, which is what we call the body of the message. But similarly, as how the HTTP protocol works, you can add headers to that message. So you have some context to your flow. For example, you can store credentials, or you can store some value that can be used on a later step, but is not explicitly included on the data that's being carried forward. Usually, most of the components, what they do is you prepare the body. So that's what you send to the external component, to the database, to the FTP server, to the Telegram bot. That's what you send. So if there is data that you need to keep in your integration, but you don't want to send it to the next step, then you can store it on the headers or on the properties there. If there's any error that gets thrown, that throws an exception during the routing or the processing of the message, or maybe you try to connect to some service and that service is down, so that returns an exception, service not found, whatever. That's also stored on the exchange. So the following step can check if there is an exception, what kind of exception it was, there was an error. So it's easier to recover from errors. For example, if you may say, if this component is not available and I received an error trying to reach it, then I can send an email to some administrator saying, hey, this component, I couldn't reach it, I couldn't finish the flow, so please check it and rerun the flow. Or I can store the data to continue the flow, to retry the flow at a later stage, or whatever you decide your flow is going to be. So it's not very hard to understand how this works. It's pretty simple, but the power it has to create integrations is awesome. And by the way, probably by now you will have noticed I'm using photos of women. All of them are relevant women in computer science. And if you are curious, you can check my slides. And on the link, on the right top link, there should be a link. Right top, there should be a link, which is not shown here. I have to fix that. Linking to their Wikipedia page, because some of them I know they are not very well known, and it's really interesting to discover these amazing women that have been hidden for some time, for so long. And some of them are alive, but we don't know them, and they are not important voices in our industry, and that's, I can't really understand reading their biographies and what they have done. So continuing with this Apache Camel, this is demo time. I'm going to try to implement this. Well, I'm not going to try to. I'm going to implement this adoption system. And for this, I'm going to use Visual Studio Code because it has the deduct extension that allows me to do kind of a workshop here. This integration is not published as is, but there are many integrations like this published on the OpenShift GitHub. I can add the link later to the slides. And this one is just implementing the adoption shelter thing. I already prepared. I'm going to run this on OpenShift using CamelK to show you also how easy it is to use CamelK, but this can be run on a normal Camel Java jar application. I already prepared the cluster to shorten the time we spend here. I should have all the requirements already. I already prepared a database, which is going to have one table called cat, which ID, name, the person it's assigned to, and an image. So when a cat arrives, I'm going to store it on this database with person as null. And when a person adopts a cat, I'm going to add the name to the table, and that signals that the cat is adopted. There's also a Kafka cluster I already created. A Kafka cluster is just, I told you this has some streams brokers, streams of messages. So I'm going to create two Kafka brokers, one for incoming cats and the other for incoming persons. And I'm going to create them so we can enter data through the command line here. So we create one. This is the topic cat, which means it will be listening to cat elements. And I create another one in another console, which is topic person, which means it will be listening to persons wanting to adopt cats. And now we can start with, this is preparation. Now we can start with the real integration, the real code. This is all the source code we are going to use for this use case. It's going to be a complete use case. And as you can see, there's more files that I would like to, but it has an explanation. Because I'm going to use a different Java file. I'm a Java programmer, so I'm going to use Java, but remember, you can use JavaScript, you can use Groovy, you can use, I don't remember any other languages, but there are more languages you can use. So that's explained why there are so many Java files. The readmes, they're not really source code, but it's good that they are there. I have a model modeling the database, which is just a class with name, image. Hey, it's updating things. That's why I don't like Visual Studio Code. And set name, set image. So when we receive a cat, it gets mapped to this class. To simplify, no, not to simplify. Usually when you do, not only when you do camel stuff, but if you want to have dependencies that gets added to your Maven project, and you want them to be on some external repository for workshop purposes, you can use Jetpack, which allows you to have this dependency on some Maven repository that you can add to your settings, not to the POM, don't worry. So it will be added. Maybe I could have simplified this without Jetpack, but I think it's interesting to mention that this exists. Let's start by showing what happens, how is the integration that receives a new cat. This is not AutoCat, this is cat input, sorry. Let's show it completely here. So this is the full piece of code you have to write to define. You receive a JSON, this JSON gets parsed, this gets converted to an insert SQL instruction, this gets stored on the database, done. Well, as I said, you listen to the Kafka cat broker. You said, Campbell, I want to start this integration from Kafka type topic cat, which is the one that is here. Topic cat. Kafka broker, topic cat on this URL, because of course you have to tell where to listen. I mean, there's no worldwide repository of Kafka brokers on your repository, on your server, which in my case is this server, which is this one. Then when I receive something, I'm going to log what I have received. And remember, the exchange had a body, so I can call body here, so it gets called and it gets filled with the body variable inside the exchange, the body attribute. Then I want to add Marshall as a JSON and convert it to the cat class, which means this is a JSON. It's going to have the same attributes as the cat class model I showed you before. Please match it. So for each attribute on the JSON, fill the same attribute on the Java class. Then we store it on the database, and we said the body we want to send to the database. Remember that usually you send the body to the next component. Is going to be an SQL, which will have body.name, body.image. We could have, why does it have body.name, body.image? Because we already did this. Body, after this step, contains the Java class cat with the attributes name and image, which is name and image. So you can extract the name and the image from the body like this. You don't have to have getters and setters explicitly defined here. So you will have on your body of the exchange the SQL to insert the cat on the database, and then you send it to the JDBC Postgres bin. Where is this JDBC Postgres bin defined? Well, on the resources, we have a Postgres YAML that says, no, sorry, not the Postgres YAML. The orchestration properties that says the Postgres bin is I want to use this specific Java class for the pooling data source. This is the server name, this is the database, user, password, and the maximum amount of connections I want to connect to the Postgres. So you can configure it the same way you would do it if you do it manually, but you avoid doing a lot of the code you usually have to do. I mean, we can finish the first the steps with almost 1 line per step. It's 2 lines per step, and we are adding a couple of logs. How do we run this? There is a camel to run it as a normal camel with no knative, no camel K. You will do it as create a jar file and then run the jar file. Perfect. But if it is as if we are going to use camel K, we can use the camel command, so we can execute it. And you can see what integrations we have. On this case, it's just the cat input. It's already running because it's very fast uploading and starting the integration. So if we now, we can read the logs, which will be quite all the starting of the log. And now it's quiet because it's not receiving any camel. It only logs things when we receive any camel, any cat. Sorry. So we can send a cat here. I prepare here a JSON, a valid JSON with a name and image. Did I execute it? Execute it. So I send it. And if we check the log of the integration, message received from Kafka, cat stored. So now on our database, we have one cat waiting. Let's stop the log for a bit and let's see what happens when a person enters the cat shelter, which is the complex one, the complex use case. The complex use case, oh, because it has a condition. So how is this? Can it be shown now? So it's going to be 40 lines of code, including logs, including white spaces, 40 lines of code to define all the, I receive a person, I check the database in case there is a cat available, I decide, and either that person adopts a cat or, sorry, we cannot do it. So the same way we started with the other integration, we start listening to a Kafka. This time we are going to listen to the topic person. We are not interested in the cats, we are interested in the person. We tell them where the URL is. We log the body. We say, hey, we have received a Kafka, which is going to be adopt a cat. We store the name of the person on one property. Why? Because now we want to check the database if there is a cat whose person is null, not assigned to any person. That means we have to store the person somewhere else, which is not the body, because the body is going to be this select ID, blah, 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 blah. We send this select to this select instruction to the database, and then we make a choice. If we have one or more rows returned, I mean, if we received more than one or more cats, on this case, we are not going to receive more than one because we limit by one, but I wanted to show how you could receive more than one cat and start looping or whatever you wanted. Then I store, again, the cat name, the cat image, the cat ID. Is it? We found a cat. Update that cat, so the person is the one we stored on the property, and the ID of the cat is the one we just stored here. And then we say, congratulations, this is another way of logging. You have seen here I log a string. I want to show that you can also create more complex body and send the body to a log. It's exactly the same. It's just how you like it, your code to look like. Congratulations. And now you start extracting the properties because you store the name, you store the image, you store the ID. If we didn't receive anything from the database, that means there's no cat with no person assigned. Otherwise, we are sorry, there is no cat looking for a family at this moment. Finish. So we can run this person input. Camel run, sorry. We can run this. We check that we have the person running already. And now we can start sending names. We send a name to the topic person. And if we check the camel if we check the log, I didn't open the log, person input. Here, message received from Kafka, Antonia. Antonia wants to adopt a cat, looking for available cats, cat found. If now we try, we haven't added any more cats, so the database should be empty of cats with no person. If we try to send someone else, it will say, oh, sorry, there is no cat awaiting, looking for family at this moment. it works. And how many lines of code did we use? Even if we count orchestration properties, the camel config, which tells you to use the orchestration properties for the integration and the dependencies, because you may want to use a different version of the Postgres database, whatever, so you explicitly set the dependencies. 200 lines of code, which you will have to maintain not many of them, because most of them are just camel DSL, and unless you mess up a lot creating this insert or creating the log, there's not many places you can insert a bug here. There's not many places you can mess up and completely create a use case that is not working. So we created the full integration. This is working. This can be already used in production with a shelter with less than 200 lines of code, and I think it's even less. And it's working. And the maintenance of this, you only have to worry about updating Camel, because Camel will make sure the database libraries are updated, the conversion between formats. If there is any bug discovered, it's going to be fixed. So it's easy. Why waste your time implementing the full integration between components when you have integration frameworks like this? And as we have time, I'm going to create something a bit more complex, which is trying to add cats and persons automatically. So I showed you 2 more integrations. The AutoCat is going to write on the Kafka stream, because right now we are just writing on the Kafka stream with a command line, which is not the best way to write when this is having the console open and interacting with the console may not be the most beautiful way of implementing this. So let's create a new integration, so you can see that you can also write on the Kafka. And it's going to have a processor, because it's going to generate random names. So on this case, it's going to be a bit more complex, 70 lines of code. Beware. And we're going to start with a timer. This means every 10 seconds, I want to run this integration. This is not going to depend, this is not going to be listening on anything, any input. This is going to run every 10 seconds, no matter what. And then we take a random image from this API that provides random cat images. Very cool. It returns a JSON, which we will unmarshal. We are not going to tell this, on the previous example, we were saying we have a cat model Java class, so it's going to be beautiful. This is not going to be beautiful. We don't create a model for this, because we can also access it by this, by saying the body, the first element of the JSON, then URL. We just have to unmarshal it, so it gets a marshal, so we can handle it properly. But we don't really need a model. The model was a fancy stuff to do. Then we process. What does the processor do? We have a list of titles, a list of first name, a list of last names, a random generator, and we create a map with 2 elements. One is the image, which is the one we just extracted from this API, and the other is the name, which is going to be title, first name, last name. And once we have that on the body, we marshal it on a JSON format, and we send it to the Kafka broker. So if we run this, and we check the log, it's starting. A new cat arrived today. This is the response from the REST API. We give this name, cat is looking for a family. Another cat arrived because 10 seconds passed. So every 10 seconds, a new cat arrives. And the last thing is having people getting to the animal shelter with not having to add it by command line. So this is very similar. We have a processor that generates random names based on a first name and a last name. And it's pretty simple. We just have a timer. Every 10 seconds, we are going to generate a random name, which will be stored on the body. We will log that that person wants to adopt a cat, and we will send it to the Kafka person broker. If you're wondering, it will not appear here because this is just an entry point for the Kafka broker. This is not showing everything that comes through the Kafka. So we can just run this auto person stuff. We check that this is working. Already, someone was a little cat. Will they find the family? We don't know. And now we are sending cats and people every 10 seconds. So if we look at the log that makes them match, we should see how they are being matched, right? And this is where person input was. Nope, camel log. And we can see that there's people adopting cats. Message received from Kafka, someone wants to adopt a cat, looking for available cats, cat found, exchange. So it's working. And you can decide that instead of a timer every 10 seconds, you can listen to, I don't know, a Telegram chat, an FTP, some input from some website, some REST API. You can listen to anything that Camel can connect to. And seriously, there's hundreds of connectors, so it will be hard if you have some use case that is not already covered. But if there is, this is free and open source software. You can either implement it yourself, hire someone to implement, ask the community, and it will be solved eventually. So this is it. I think this was everything I wanted to show. Just wanted to tell you that if you have any questions, you can find more information on the Apache Camel's website. Synthesis is a web interface for this. So if you are even scared of these small pieces of code, you can do the same things, but drag and drop. And my presentation is going to be on this website. And you can reach me. I'm Delaware on Twitter. I have also Delaware@gmail. You can contact me and ask me any question, and I will try to answer as good as I can.